Go for it. I have your name listed. Worst case, I can have you fill out a form, the other form later.
Your rules are different if you've had faculty or staff.
Technically, it's a clubs thing, and now it's streaming. So, yeah. All right, and the stream is live. If you want to watch it, you don't have to. Actually, that wouldn't make any sense for you guys to be watching it. God, I'm so glad that we're recording.
What's the link?
I will send it. I don't have Slack open because I'm going to be presenting. That's been a problem in the past, so I'm going to get the link off my phone and send it to you. You can put it in the NextHop Slack. Which, actually, I'll just do it myself. Both work. Yo, you spilling stuff back there, Matt? Okay, that's good. Thomas, I sent it to General if you want to check in there. Looking good, thank you. Glad I got my hair cut before we did this. Right on the board too, just in case people come in. How's the pizza, guys? Is it good?
It's not salad.
Yeah, that is sparse pizza.
Oh! Don't let them hear that.
I feel like already calling my hours.
Yes, because we use TLS here. And it redirects anyway, but you know. So the answer is no, I didn't, but it's okay. Hey, sign in, grab some pizza. At 6:10, we're going to get started. Right there. Yeah.
Still haven't decided about that house yet.
Oh, that's fine. I didn't realize that was you, by the way. I'm bad with faces to names. Nice. Let me know. Now that I know that you're not a complete stranger, it's even better. So. I'm actually going to grab myself some pizza.
That's why I'm here. You saw me as well.
See, you made it easy. I would have signed it for you.
Hey, Peter and Tyler, make sure that you sign in as well. If you can.
Oh, yeah.
Just so that we have an accounting of that. Yeah. And log in with your RIT account when you do it. Otherwise, it won't let you fill out the form.
Oh, so only my Sprint account.
You were going to what? Okay. You know there's a camera recording what you're saying in the front of the room.
I mean, that's cool.
Okay. It's fine because you mumbled it anyway. So. Sweet.
I like that Windows 10 background.
Even better, it did my screensaver. Don't want that. I have a lot of creative wallpapers on my computer, and I specifically set like a safe for work one, and then I walk away, and that's displaying on the stream and up on the screen. Like, great. I have to make sure that stops. So. Cool. This is upset. I want to see what happens. Switched to a Mac recently, and it's been difficult. So there we go. There. Now I've done all that, I think we can probably get started. Okay, welcome. Thanks for coming. We're NextHop, in case you didn't figure that one out. Today we're going to be doing Tech Talks, first time for the year. I don't really have any other news, but if you didn't sign in already, please do. We're going to have 4 speakers. First one's going to be Anthony Critelli. Then I'm going to do a presentation on Ansible. Joel Margolis is going to present after that, and then we're going to have Thomas give a presentation. So, Anthony, if you want to come on up here, we'll get started.
Replicate the slides to the stream?
Yeah.
That's pretty cool.
Yep. Thanks, Barca, for the streaming equipment they loaned to us. It's wonderful. So it should display up there and on there.
Cool. Hey, look at that.
Okay, perfect.
Sweet. Cool. Howdy. I'm Anthony, the sysadmin for IST, for anybody who doesn't know me. And I'm an alum of RIT. I graduated in 2014 with, I don't know if it still had the word applied before it, but Networking and Systems Administration. They change the degree names every few years. So I'm going to talk about, I've been doing a lot of work in VMware and around networking in VMware and some of the ways they solve networking problems. I think Joe just got tired of hearing me talk about it, so I think he was just like, you know what, just come and get it all out and give a NextHop presentation. So I'm really, most of my background is in network engineering, classical route switch stuff. So seeing what VMware does virtually for networking kind of has me excited because it's really cool. So real quick, I'll kind of go over what challenges we have that we usually try to solve in virtual environments that are sort of unique to virtual environments. Talk about kind of generally how you can solve them, like in a vendor agnostic way, and then kind of show, like, give an overview of what VMware is doing. And I could talk for hours about this, so I won't be doing that. So it's always important, like, technology is cool and it's fun to play with new toys, right? But like it's good to know what you're actually trying to do with a piece of technology. So if we consider how, like, when networking first started, you know, and TCP/IP was gaining popularity and stuff, how did we configure networks? Oh, you were using PuTTY or some kind of serial, you know, you're serialing in or whatever. You're using a console cable, right? You were doing, you know, your config commands and really just kind of artisanally crafting router and switch configs, right? So we fast forward 20 or 30 years, we made all these advancements, some of the greatest minds in networking have focused on the issue, and how do we configure things now? In the exact same way, like literally the exact same. Like nothing in the management plane of networking has seen any substantial change in 30 years. Now it's kind of fascinating if you contrast that with the server world, right? Like you've gone from, you know, artisanally crafting physical servers to, you know, moving into virtual environments to spinning up virtual environments quicker with automation tools. And the land of server administration has seen a ton of advancement, and networking really is almost completely stagnated. There's been advancements in data plane protocols and stuff like that, but for the most part, BGP, OSPF for your control plane, and some awful console interface for your management plane, and that's kind of the way we've rolled for 30 years, and nobody's actually bothered to make any meaningful change to that. So why is that a problem? I mean, it's not necessarily a bad thing that we do things the same way unless it's actually causing pain points. So the biggest problem is you can't really adjust to changes in your environment easily if you have to log in and change things individually on every switch in your environment. And somebody, you might be thinking, well, you can script it, and you can, but you really can't script networking devices in a meaningfully deterministic way. So usually you're screen scraping some config off a router, you're crossing your fingers and hoping that you're getting the right output, and then you're going to blast some config into the router with a script, and it's really not a good way of doing things because you can't guarantee without a lot of very careful coding that your screen scrapes are accurate. There's really been no meaningful API for any network device, and we're just starting to see some of those come to light. So, you know, making any sort of change takes a long time. There's no single pane of glass, and your network becomes a very blurry kind of picture, right? You often hear about server admins referring to networking as some kind of black magic, and that's very, you know, very much because same thing in the troubleshooting arena. All we really have is ping and trace route. That's how we troubleshot for 30 years. No advancement. There's always room for error when you're making these changes manually and by hand, right? If you've ever taken down something production by forgetting to use the add keyword in front of a switch port switch port trunk allowed VLAN, you'll know what I'm talking about, right? This is an error-prone process doing everything manually, and we can't automate it. So, like, as an example that we can consider to nail this down more concretely, let's say I work for a company and I have developers, and they all want me to spin up identical multi-tiered application networks so that they can work on the application they're developing. So how do we do it now? So your typical simple virtual topology right now, you're going to have a couple of ESX hosts trunked down to a switch, several hundred VLANs depending on the size of your environment, and then you're going to have on your virtual side, on your host, you're going to map those VLANs to port groups, right? And you're going to plug VMs into those logical port groups, right? So if I want to fulfill that developer's request in this kind of environment, I need to bring together a bunch of different teams and do a bunch of different things manually to make that happen. So I've got to add the VLAN on every switch in my environment, or use VTP, which you just shouldn't do because it's awful. And then I need to add that to every single uplink. And depending on your environment, that might be a change window, right? Like now going back to the example of making a mistake and forgetting the add keyword, you forget to do a switch port trunk allowed VLAN add on an ESX host that has 300 VLANs associated with it, and you blow out an entire production environment. So you have to do that. That's going to require coordination of your network team, your server team, maybe your change management team. You have to go through and add a port group on all your hosts, or just to your distributed virtual switch, which you're hopefully using. You have to add all those VMs to the correct port group. You may even need to re-architect your network, right, in certain scenarios if your hosts are on different subnets, right, because you can't span a VLAN across multiple subnets without substantial engineering effort, right? So usually in most environments, this stuff isn't hard, but there's a lot of effort that kind of goes into it. There's a lot of engineering effort and a lot of room for error and a lot of room for mistakes. So ideally, that developer would ask me for a logical environment, and I would just click a button, and there they go. They have their logical network, right? Like, who's used AWS before? Right? Like, that's exactly how you deploy a network in AWS. You click, give me a network, and it gives you a network, right? That's what people want. That's a quick, efficient way of doing things. So that sounds cool, but, like, how do you do it? What technology stack would we use to accomplish something like that? So one approach is to use overlay networking, to create some kind of overlay on top of our regular network that basically creates some kind of logical virtualized network in between all our hosts, right? We don't necessarily care about how packets get from point A to point B, although there's this thing called the law of leaky abstractions. It was a term coined by Joel Spolsky from inventor of Stack Overflow, if I remember correctly. And you know, he coined this term, law of leaky abstractions, where when you abstract anything away, that abstraction, the underlying abstraction tends to leak up the stack a little bit, right? So, perfect example. If you deploy a layer 2 network that stretches the entire country, you're going to run into latency, right? That's the abstraction leaking. You know, your VMs may think they're on the same layer 2 segment, but you know the 1,200 milliseconds of latency between the two is quickly going to reveal that they're not. So, you know, you still have to keep those kinds of things in mind. But I mean, in general, those hosts could be on different networks in different physical data centers. As long as they can talk to each other, the packets can still flow in virtualized networking. So we definitely need some kind of actual concrete protocol or technology to handle that. But first, I find that it tends to be a little tricky to wrap one's head around the concept of overlay networking. So an example that everybody knows is just using a VPN, right? A VPN is a form of an overlay network. So if you have two hosts in different branch offices using, say, IPsec, they think they're on the same layer 2 network, right? Layer 3 network. They have no idea about the complexity that exists in between. The IPsec protocol doesn't care about the complexity that lives in between them. There could be tens of hundreds of routers for all it cares. And all that really matters is that there's this logical network that exists between them. So that's a simple overlay network that we've all probably worked with before to kind of give you an idea of what we might be looking at. So one proposed solution to this is to use virtual extensible LAN, defined in RFC 7348, or VXLAN as you'll typically hear it called. This is a wonderful graphic from the RFC that actually is actually fairly instructive. So basically what we do is these are our hypervisors, right? This is our layer 3 network that we don't care about the details. And we create little virtual networks and we give them identifiers, much like we would a VLAN in a traditional network. That's called your VXLAN network identifier. We put a header with that ID on every packet we send, and then it can be encapsulated and decapsulated by the ESX hosts, or your virtualization host. It's not VMware specific, right? And these hosts end up in this topology are called VXLAN tunnel endpoints because they're the endpoint for the tunnel. They're the ones that are responsible for assigning those tags and stripping them off on the other side, right? So what does that packet look like? So this is I took most of these graphics from the VMware NSX for vSphere Virtualization Design Guide. They've got very good graphics and very good descriptions. So I grabbed this picture of a VXLAN encapsulated packet. So if we take here, we have our original Ethernet frame that looks exactly like what we would have. Let's say this VM wants to send a ping to this VM, and they're on the same, that 22 logical network. So the original packet is just that original echo request, right? That's the inner packet here. We strap on this VXLAN header of 22, and then we have an outer outer Ethernet IP UDP stack. So VXLAN runs over UDP. The UDP header on the source port is calculated by hashing together the values of the original headers that are in the original inner packet. And we put on our outer Ethernet header and our outer IP header. So if this guy was talking to this guy, the inner packet would be the inner communication from this guy to this guy, and the outer packet would be the MAC and IP address of this hypervisor going to this hypervisor. So we're just encapsulating, right? So now at a simple level, I can take my entire network with hundreds of VLANs and collapse it down to one single VXLAN network with a single subnet if it was in a single data center, right? I have one subnet that carries all of my networking on top of it as a single underlay. Drastically simplifies my physical network. One benefit being that I can stop buying expensive hardware because I don't care about the feature set. All I need is for my switches to get packets from point A to point B really fast. I really don't care how many VLANs they can hold or anything like that because I'm not doing the networking on the underlying data center fabric. So there's lots of things you actually need to consider when you approach this kind of architecture. So you're adding more headers, you have to consider your MTU, right? Your maximum transmissible unit. That's easy in a data center environment. You just go to your switches and you bump up the MTU. If you're spanning WAN environments, you have to work with your carrier to make sure that the MTU end-to-end is big enough to support carrying the VXLAN packets. So that's a very important consideration. And it's a very easy thing to miss, and you can spend a lot of time troubleshooting MTU issues, which if you ever troubleshot VPN issues, you'll know that typically it's an MTU problem when you have VPN problems. How do you handle ARP broadcast and unknown multicast, or excuse me, ARP broadcast multicast unknown unicast traffic, right? So we now have these virtual networks. We still need to have an ARP request populate through to be able to get the the corresponding layer 2 address for an IP address, right? So this is kind of where everybody does something a little bit different. Most vendor implementations will give you some kind of controller option. So you'll have a logically centralized controller, right, that knows the IP address and MAC address mappings of every VM in the topology, let's say. And it can just intercept an ARP request, say, oh, I know where this guy is, and send back the corresponding the corresponding layer 2 address, right? So we intercept those ARP requests and we can reply easily. The other option is to use multicast. So if you have a bunch of hosts, let's say I have a couple of hosts here. Let's say I have 3 hosts. So pretend these guys are all on one network, right? And these guys are listening on virtual network 22, and this guy doesn't have any VMs on virtual network 22. Well, I can multicast out that traffic just to these 2, right, using your standard multicast protocols. And this guy, since he doesn't currently have any VMs on the network, he has no need to know about any of the broadcast traffic on that network, so he's none the wiser. So that's one option as well. Multicast is, in my experience, a nightmare in most real networks. Nobody actually likes using it because it's awful. So, but your mileage may vary. You can do it if you don't want to rely on a logically centralized controller. But the bottom line is that no matter who you talk to who's implementing VXLAN, they're usually doing something ever so slightly different in their own vendor-specific way. But it's usually relying on VXLAN as your overlay protocol in the end. So what's VMware doing? Lots of stuff. So they have a network virtualization solution that does this exact thing called NSX. There's a lot of components involved that I'll discuss really quickly. It integrates very tightly with vCenter. And there are actually 2 flavors. There's NSX-T and NSX-V. V is the vCenter one, V for vCenter. T, or V for vSphere, I should say, because it's the vSphere one. T is very new. It's designed to be multi-cloud, so it's designed to manage your on-premises vCenter environment as well as your AWS environment and potentially additional clouds in the future. I won't spend any time on that because it's extremely new, and I'm sure it works just as well as the sales guys tell you it does. So you just go right out and buy it and early adopt. So what features do you get out of NSX? Well, there's a firewall feature, there's a switching feature, there's a routing feature, there's an edge feature, there's all kinds of crap, and you can do it all in your VMware environment. So I'm going to talk about each one of these, but we get microsegmentation with the firewall. The switch implements that VXLAN overlay that I was just talking about. Routing will basically take your routing and logically distribute it in a way across all your VMware hosts. And then Edge, you can do all kinds of things like load balancing, VPN termination, DHCP, NAT, all the standard network services that you might expect out of basically a very advanced home router, right, in a way. So the firewall tends to be, in my experience previously when I was working for a consulting company, that's people's kind of gateway drug into getting an NSX because it's so easy to use and it's so centralized. So basically, the firewall, the distributed firewall, provides you with one single pane of glass to manage all your firewalling across your entire virtual environment. So let's say you have 20 VMs and you want to deny access a certain IP address to those VMs, right? You can do it in one single place. You can create a group of those VMs, put those VMs into it. VMware knows about them, so you're able to visualize them very easily, and you can create that rule. This totally bypasses the host firewall, which is extremely useful, because implementing a hypervisor firewall means now if you're in a development environment, you can give your developer root access on the VM, and you don't have to worry about whether or not they turn off the firewall. They can, but you still get to control the policy at the hypervisor layer. You can do dynamic stuff, which is really neat. So you could say, any VM that I tag with the dev tag, or I name with the word dev in it, should have these firewall rules applied to it, and that's a totally dynamic process, which is pretty sweet. And one of the cool things, we traditionally enforce security policies on layer 3 boundaries, right? So we put our systems into a subnet, and then we enforce firewall policy at the edge of that subnet. So this network can't talk to this network, right? Because you have a hypervisor layer firewall, you can enforce policy between VMs on the same network, because that traffic has to traverse the hypervisor at some point to get from one VM to the other. So you could literally collapse your whole network into one broadcast domain and enforce policy basically using the distributed firewall functionality. Probably not necessarily a great idea for a slew of other reasons, but it is, I mean, technically possible. And you can be very granular. And the firewall also has really cool third-party integration. So you can say, have an IDS that when it detects strange traffic behavior on the network, fire off an API call to the distributed firewall to black hole a VM or something like that, or block a specific piece of traffic. It was pretty sweet. So one of the things when I was at VMworld, their instructor talked about that was very useful is he showed off how this actually kind of works in the hypervisor. So when you have a guest VM sitting on top of your hypervisor, there are all these like slots in between the VM logical NIC and the hypervisor itself. One of those gets filled with the distributed firewall module, but additional third-party integrations could do other things. Like you could have some kind of module that redirects traffic over to another VM to inspect it for IDS, IPS purposes, and then makes a forwarding decision based on that. So the logical switch is the VXLAN piece of this. This is where we can deploy logical networks on top of our physical underlay. So it is VXLAN based, and if we take this and combine it with all the other NSX components, we can deploy an entirely logical network without ever touching a physical piece of infrastructure, which is kind of cool. And we can even do it programmatically because the NSX has a very good REST API, one of the better REST APIs within the VMware product suite. So the distributed logical router basically takes a routing module and places it on every host in your environment. So this solves one important issue that if you've worked with VMware or virtualization for a while, you've had, and that's traffic hairpinning. So if you have two VMs on one host, and they're each in different subnets, in order for them to communicate, they have to go out of your host, talk to a router on the network, come back into the host to go to the other VM, right? That's like grossly inefficient. But if you put a logical router on each host, a logical routing module, now this traffic can stay totally within the backplane of that host. And additionally, you can also peer your VMware network with traditional routing protocols like OSPF or BGP. So you can build this whole isolated VMware-only network, and then you can peer it to the outside world using one of the logical routers. So I'll take really quick breeze through what the architecture looks like because I don't want to bore you too much. But it's basically like any other network. You've got a management plane, a control plane, and a data plane, and components for each one. So the management plane is this thing called the NSX Manager. You deploy it as an OVA, just another VM in your environment. And it tightly couples itself with vCenter. You bind the NSX Manager to vCenter after you deploy it. And then you do all your configuration in vCenter, and vCenter talks to that manager, and then the manager pushes things down to the rest of the NSX components. And this is also if you wanted to make API calls into NSX to programmatically configure your network, you would point it at the NSX manager. That would be your API endpoint. The control plane is a cluster of 3 controllers that get deployed. They're also VMs on each cluster that you want to enable NSX on. This is done during NSX setup. You do this right in vCenter. You say, hey, I want to prepare this cluster for NSX, and it goes down. It deploys 3 of these controller VMs. You just tell it what IP addresses it should use for them, and it goes down and it pushes them down onto the network. If you end up deploying this on your own, if you decide to try it out, you should create an affinity rule that keeps those 3 VMs on separate hosts, because if they all inadvertently end up on one host and that host dies, your entire network is now down. So you want to spread out that risk a little bit. And then if you're using the logical router, that also deploys a control VM, which is actually kind of cool. You can SSH into this VM. You can run show IP route commands and stuff just like you would a switch or a router. So that's the control plane for the logical router. And then, yeah.
How does the CLI look? Is it Cisco, iOS type stuff?
A little bit, yeah. I don't remember. I'm blanking on what they use as their flavor of the underlying routing daemon, but it is iOS-like. But typically, you're going to do all your management from vCenter anyway because it's all in there pretty easily. But yeah, SSH is turned off by default on which is probably good. But I mean, you can turn it on. It's a checkbox.
Okay.
But it is Cisco iOS-like.
Cool.
And then your data plane, what actually handles the forwarding decisions, what decides whether or not a traffic should be allowed or denied, what decides what VXLAN header to put on it. These are these little kernel modules that get pushed down to each of the ESX hosts through vSphere Update Manager. And that's what really all your data plane is. And if you have an edge appliance doing something like NAT or load balancing, that's obviously also a data plane because that's handling those functions at the edge of your network. So what's it actually look like? So managing, There's a vCenter GUI. When you install NSX, it adds this networking and security button on vCenter. You click in there, that's your single pane of glass to view your basically your entire network environment within VMware. It's got a set of REST APIs that you can point at the NSX, or you can point scripts at the NSX manager to make RESTful API calls. And most everything in the interface can be controlled through the API also. So you could, going back to my original let's deploy a network for a developer, you could do that totally programmatically and have easily recreatable environments for all your development team. And that can obviously be automated with an actual tool. You could use like Virtualized automation if you wanted to go all VMware. You could use your own stack of tools if you wanted to. Adding a new network and connecting a VM. So this is really cool. All you do is you create a new logical switch. You give it a name. You click OK. Right? It's going to deploy a logical switch that now spans your entire vCenter environment. You go over to the VM. You figure out what VM you want to attach to this logical network. You right-click it and hesitate while you look for edit settings. You find edit settings, right? And then you just connect the VM to that network, right? That's it. So basically, I've now deployed and I didn't speed that up at all. If we go back to like my, I don't actually remember if I have an example of this. If I go back to my developer request, which I've now lost, let me go through here. I basically deployed the entire left half of this network in, under 20 seconds. Probably less if I knew what I was doing better and didn't have to sit and stare at the screen for a second. So that's really it. That's all you have to do to deploy a logical layer 2 network. If I want to add some firewall rules, it's also easy. So you can see I've got a VM here that can clearly ping another VM, right? All I do is go to the firewall. This is single pane of glass. You can see everything, all the firewall rules on my VMware network. Add in a new rule. Give it some kind of name. Think about what I want to name it for a second. Type it out, click OK, right? And basically just give it a source and destination. Now you can do source by all kinds of things. You can say that your dev cluster should never be able to talk to your prod cluster. Your dev resource pool should never be able to talk to prod, anything like that, right? But I'm just going to go with a simple VM rule here. So I'm just going to grab a VM out of this list, add it as my source, click OK. And because vCenter has knowledge of all your VMs, you can like pick VMs instead of IP addresses and things like that. And then the same thing for your destination. We just wait a little while for the vCenter client to load, and you can search through all your VMs. It's surprisingly quick. There's probably about 10,000 VMs on this cluster I was messing around with, and then you just pick your action. It's just like any other firewall rule, but you don't actually have to like do it by IP address, which is kind of nice. And then you just publish your rules, right? And that's it. They're instantly applied across the network. And now if you go here and look to see whether or not our ping still works, it's now broken, right? So very easy to do that. I don't have to worry about segmenting things on layer 3 or putting something into a different network just so I can apply a rule. Nothing like that. I can just apply it instantly from one pane of glass. So to quickly recap, traditional networking tends to fall short, right? And this is not true of all environments. Like you'll go into a relatively static environment that has no need for this kind of additional functionality, but you'll definitely run into some networks that you work in where you're like, man, why do we have to talk to the network team and the server team and this team and that team and all these teams to get the same, to get this one thing done? And oh, look, they forgot to do this, and now this is broken. I mean, you will have environments where this kind of thing is useful, and it's useful to automate these tasks, right? So one way you can accomplish this is using some kind of overlay network. NSX provides that. That's sort of their tool. Things I didn't talk about, load balancing, NAT, DHCP, all those other network services that are pretty common in your network. It'll do those too. And it integrates tightly with vCenter. It's got a really nice interface. You can use a really nice, well-documented REST API. And one thing you'll notice is that I just talked about networking for 25 minutes and never mentioned hardware. So I didn't discuss what kind of switch we were using, what kind of router we were using, whether or not you needed some kind of specific ASA to do some specific thing. It's all just done in software, which is pretty sweet. Any questions? I post these slides up on my website. I have notes in all the slides because I try not to read off of them, and I talk fast. So if you're interested, they're on there. But anybody have any questions? All right. Thanks. Next up.
Thanks, Anthony. It was a good talk. I am up next, so.
And in case you filtered in, please make sure you sign in at that URL so we can keep track of who's here. No worries. Oh, there's only the one plug. Nice. Set this up like 20 minutes ago, and it's all tangled. Lost where the cable was. Okay. Perfect.
Next.
Oh, no. There we go. Okay. Hello. I'm Joe Graham. I'm going to be talking about Ansible. Those who don't know me, I'm a fourth year CSEC student, president of this club, member of others. Worked with Ansible a bunch all through this summer, setting up infrastructure for a cybersecurity focused summer camp, and ended up building out a bunch of Ansible playbooks that you can use to automatically deploy those. When I was doing that, I basically fell in love with how easy it is to use Ansible. That's why I'm here. And that's my username on Slack. If I say anything wrong, or if you don't like my face, or if I say things that you like, shoot me a message. I'd be happy to talk more about what we're talking about here. So what is Ansible? It's a lightweight automation engine. It's a tool that automates systems administration tasks. So basically, if there's something really annoying that you want to do on a bunch of your hosts, or if you want to set up infrastructure very consistently over a lot of time, or over on a lot of different systems, Ansible is your guy. It's agentless, unlike Puppet and Chef. You don't need to install an agent on every single host you're setting up. On Unix and Linux type machines, all you need are Python and OpenSSH. For Windows, all you need to do is turn on PowerShell remoting. And then there's also support for some other platforms, including ESXi and vCenter, Aruba wireless access points, and Cisco iOS from 15.6 and up, iOS XR, ASA, and Juniper stuff. So what I'm going to be doing, I'm going to go through a bunch of terms, going to show some playbooks, going to demo what they do. So what is a playbook? A playbook is a collection of plays that Ansible performs, and plays are just tasks that you want to do on a bunch of hosts. Playbooks are basically set out in a YAML file, which stands for YAML Ain't Markup Language. That's a file that's supposed to replace JSON, and it's actually human readable. It's awesome. Looks something like that. Basically, you list the hosts in a group that you want to actually, you list the hosts in a group that you want to perform the thing on, and then you just list the tasks that you want to do. The two modules on here are package and service. Package does what you expect. Depending on what type of Linux machine, it uses apt or yum or DNF to install that package, and then service makes sure if it's on, enabled from start, stuff like that. So like I said, tasks are things that you want done on a system. These are written as modules. They're little bits of Python and PowerShell that perform whatever task that you want done. If a module doesn't exist, you can use shell, exec, or command, which literally just runs whatever commands that you want done out there. And because Ansible is free and open source, you could write your own module to do that, and then issue a pull request, and they would pull it into their code if they approved it. So we also have an inventory file. This is how you tell Ansible what hosts you want to deal with. They're files that contain, it's a file that contains all the hosts you want to deal with. By default, Ansible will use etc Ansible hosts. You can also specify a different file by using the -i flag. This lets you mix different repos that have different Ansible playbooks just by pointing at one specific inventory file. It looks like that. So list out the hosts as you want. IP addresses or DNS names can go in there. And these little things up here are what are known as host variables. This is just information related to whatever host you're messing with. You can also access a bunch of things related to the actual machine that are different depending on what you log in. It's called facts. We'll talk about that a little bit more when we get into some of the playbooks later on. But wait, that last slide had passwords on it. That's not secure at all. Reason for that, Windows machines don't support SSH, and WinRM PowerShell remoting doesn't support keys. They support certificates in sorta. I haven't really messed around with it a lot, but it's not easily done like with SSH. You can also use Kerberos if your hosts are connected to a domain, but if you're just using a local machine, obviously you can't do that. So Ansible, in their wisdom, was like, we should create a tool that can encrypt files that will contain credentials. So created Ansible vaults. It's just a file encrypted with AES, I don't know, an inventory file with administrator credentials. You can create it using the create command, create a file that you're going to use as an inventory file, or you can encrypt an already existing file. The only difference you have to do is you just have to pass an extra option to the command when you run it, and then just type in the password for that vault, and you're good. So how do I run these playbooks? Weirdly enough, the command to actually run it is Ansible-playbook. You can specify the inventory file, -u to specify the user, and then you just give the name of the YAML file that you want to run. Modules can also be run directly by just using the Ansible command. These are what are known as ad hoc commands. I have an example of one up here, which uses the management admin user to send the firewall, the netsh command to a bunch of Windows hosts to turn them off. I had to do this over the summer. We joined a bunch of hosts to the domain as an exercise in the summer camp, and then I realized that I could not RDP into any of them. So from my Ansible control machine, I ran this command, which you probably never want to do in a production environment, but in this case, it was exactly what I wanted to do. Allowed me to get back into my machines. It's great. So do I need to log in as root to host them? No, don't do that. You don't have to do that. You can use the become directive, which actually was in one of the examples before, and it will be in an example coming up. Basically, it's the equivalent of using sudo on it literally uses the sudo command on whatever host you're running it against. You can also configure it to use su, and I think one other thing, if you're using a really old host that doesn't have sudo on it, or a weird BSD host or something. It requires you to just enter the password to give to sudo on the command line, and you just have to give another option when you run Ansible-playbook. So, now I've talked about a bunch of the terms. Let's take a look at some examples. This is sshkey.yaml. This is a very convenient playbook that a friend of mine, Nick Piazza, wrote for one of a project that we were working on with Ansible. Basically, what it does, it takes whatever key stored in tilde.ssh ansible.pub and pushes it out to the hosts. It pushes it out to whatever host you specify. So in here, it would push it out to all of the hosts. What's going on right there? That's the when directive. That's the equivalent of an if statement in Ansible. So Ansible_OS_family is a fact. Talked about that before. Facts are just information that Ansible gleans about a host when it connects to it. And one of them is what distribution of Linux, what family of Linux, what kernel version, stuff like that. So you can specify, all right, this thing doesn't work on CentOS minimal. So only make sure that libsc Linux Python is installed if it's a Red Hat type operating system. Otherwise, just skip it and keep going. Next, these little curly braces here are replacement characters. It tells Ansible to look for whatever variable, or in this case, another fact, in either the variables in the inventory file or basically anywhere that would be declared, and to just replace it in the file there. So in this case, user is whoever you're logging into the host as, because otherwise authorized key won't like do anything. It'll be like, hey, what user am I placing this key in for? Last thing, lookup is actually its own weird little thing. I didn't know that it wasn't a function call until today when I was writing this presentation. It's called a lookup. So basically, like, it's just called a lookup. You can look up various different pieces of data outside of Ansible using this like function. So in this case, the lookup function is looking for a file on the current host using the pub key variable. And it takes the contents of that variable, effectively just doing a cat command, and puts that into the key directive. So this one would need both -k because it's using the become directive, and -big K, which is a directive that tells you to look for a password when you log in. What's up?
So the playbooks are kind of like functions that you can create for this
Ansible, yeah.
Ansible. Yeah, so they're kind of like functions that you can create.
So they're not like functions, they're basically just lists of tasks that it tells it to do. It's kind of hard to describe it in a programmatic term other than just a list of stuff to do. So, what's up?
Equivalent to a macro?
Say again?
Is the playbook equivalent to a macro in the general terms? You want to put it that way?
Yes. What do you mean by macro? Like,
You're saying that a playbook specifies the set of tasks which you need to automate, right?
yeah.
That way you can, in generic programming languages, we assign a macro to do that stuff.
Okay. Yeah. In a way, that would be that. It's kind of different from that, but that's like the closest approximation you could do to put it in programmatic terms. So, okay. I'm actually going to run this playbook against my CentOS machine. I have a user called demo that I can only SSH in as I can only SSH in using my password to get there. So let me get that IP. 10.0.10.4. Asks to authorize, and then asks for my password. You can't see it. Cool. You're right. So I got to do this. Sorry, I'm still getting used to the Mac. Okay. Cool. Can you guys see the screen? No, you can't. Even better. Do this way instead. Present. iTurn. Cool.
Command plus.
Thank you. I'm also getting used to having a Mac now. So I used to do Windows a lot. Okay. So as you can see, I can log in, but I have to type in a password. That's super inconvenient. So we're going to use the SSH YAML script. The only thing that I changed, I didn't want to have to display all of my SSH keys, so I just told it to look for the key in the local directory. So if I do Ansible-playbook, go to the Linux inventory file, log in as demo, and ask for a password. I tells it to look for an inventory file in the local, like outside of the default one, which is
kind of like CD.
No, it's just a different. It just tells it to look for the file in a different location, because by default it'll read it in Etsy Ansible hosts, but we don't want it to do that because I actually don't even have anything in there on my Mac. So this tells it to look for the file in a different location. In this case, Linux inventory. So do that. .yaml. It should ask for a password. gets upset because I used the wrong type of K. I gave you a password. What? Oh, I had to do both Ks. That's annoying. I practiced this demo before, but you would think that if you only had to do one, it would figure out the other one. Okay, so it adds the local SSH key for the current user, and now I can just do the SSH command again, log in with the key. So, there you go. Alright, next up. Get my presentation back. Okay. So I'm going to take a quick detour, tell you how to quickly enable WinRM in Windows. These are not settings you normally want to use in the real world because this will tell the Windows machine that anyone can run WinRM commands or like git shells on your PowerShell machine or like on your Windows machine as long as they have like username and password on your machine. So like it's not as bad as like, oh hey, here's a shell that anyone can connect to. But if someone gets your credentials, they would be able to more easily get shells on your machine through WinRM. So yeah, I already have this in the Windows VM I'm going to use, but I still wanted to show it on screen because these commands are super useful. So, all right, next up is a very simple install Active Directory playbook. In Windows, you have to, well, this remote _ user directive allows me to not have to do -u and then give that on the command line. This just puts it in there. When feature does what you think it would. It makes sure that a feature is installed on the machine, and if it isn't, it installs it on there. This part tells it to install the management tools as well, so I can configure it, and then it reboots. So let's run that one. Okay. So command here, I want to point it at my Windows inventory, and then just do install Active Directory, and that on its own should just work. All right, so that's going to take a little while. I'll switch over to this guy, log in, just so I can show you what happens when it tries to restart. We got our server. It's kind of hard to show, and Active Directory takes a while. So I'm going to move on to the next slide, talk about that a little bit. But this is going to run in the background. It's going to restart. It's going to be great. So let's switch back there. Okay. The last example I'm going to give is a fantastic promote domain controller playbook. This I'm very proud of, but is also like another thing that you wouldn't really want to do unless you're doing like a test development environment. So it makes sure that the domain exists using the win_domain module. That module like does a check to see if the domain actually exists, and if it doesn't, it creates it. Then it reboots the server if it needed to create it, because otherwise Active Directory fails to install. And then this part promotes it to a domain controller given those settings. So let's see. That's going to take a while to restart. So I'm going to take a moment. Ah, cool. Great. Did it immediately. While this restarts, do you guys have any questions about what I've been talking about, or like Ansible in general? I know I was talking kind of quickly, so if there was anything that didn't make sense, feel free to ask. What's up, Matt?
So like in the production environment, would you just not use Ansible on Windows machines in order to, or like, is that, because you don't want WinRM enabled, right?
So you would secure, you can specify untrusted hosts. I'll actually go back to that slide. So this part right here, this just tells it to allow anyone to log in. So in theory, what you would want to do is you would want to limit the number of trusted hosts, or like based on IP address. So that can be specified, just like give it a list of IP addresses that are trusted to connect in and do WinRM stuff. You would just keep that to the control server or any other servers that you would want to have access to WinRM. So, good question. All right, so this is done. Thank you for allowing me to stall. So if we log in here, give it a minute for it to open Server Manager, it'll pop up and it'll say that Active Directory is installed and DNS as well, but that it still needs to be promoted to a domain controller. So we're going to run our promote domain controller playbook as well. That should come back pretty quickly, and it'll be great. I gave this thing 8 gigs of RAM and it's still moving slow. Open in Server Manager. I love it. Yeah. You give it all the memory and it still takes a while for Server Manager to open. Well, this is on an ESXi server, so don't worry. Yeah, no, I wasn't going to run like 2 different VMs on a local computer while I'm trying to do a demo. That would be terrifying. Okay. And even then, it still takes a while. Yep. So you see the management tools were installed. In a moment, it'll pull up. You see Active Directories right there. But DNS isn't installed because we haven't done the last bit of, if you guys have configured something before, this bit where you're like, oh, I got to promote it to a domain controller. We're going to do that. We're using Ansible. Oh, don't do that. That's not a file. So that's the one, you saw that gathering facts took a little while there. That's like one of the few things that I don't like entirely about Ansible, but that you can configure. Every time it connects, it will get like a ton of different information about a Windows host or about any host that it connects to, even if you don't need that in a playbook. You can tell it not to gather facts, I believe. Yeah, you can tell it not to gather facts in a setup file. If you want to deploy things really quickly, I would suggest doing that. So this is ensuring that the domain exists. If it isn't, it's creating it, which also is going to take a little while. Afterwards, it'll promote. What's up?
Is there any way to tell it to gather only the facts that you reference in your plays?
I don't know. Okay. I don't think so. That would be phenomenal. Like if it could just look through and go, okay, I want to grab this information. But yeah, that's a good question. I think because it's so like varied how it does that, it would be difficult to implement. But that's a good question. So. Sounds rebooting. So while that does that, I'll actually show you one other thing that I did differently in the Active Directory. The promotion one, I got to jump all the way up to this guy, so give me 1 sec. Okay. So when reboot, normally that waits for the machine to come back. It does pings and tries to like connect into WinRM again before it comes back to make sure that it actually comes back. You can specify a reboot timeout because sometimes that can be super janky, or it will like wait longer than you want it to. Or if you need to do other things after the playbook that don't necessarily require that specific domain controller to be used, or like that host. So I specified after 3 minutes to just bomb out because I wanted to continue on to the next part. So I'm going to come back to this part of the demo, but I am going to get to the conclusion here. To conclude, Ansible is great. Need to spin up test boxes for specific environments for your devs. Like if you want to say, give someone like your web app, MySQL, and a small environment while making sure that people don't like misconfigure the settings, use Ansible. Need to deploy a large infrastructure for say a competition by just pressing a button and watching it go, use Ansible. If you want something that will support you through sickness and through health, use Ansible. So that's my presentation.
Did you find any things that the Windows module wouldn't do that you wish they did? Or did you find that the features were pretty good on the Windows side?
So the only thing that like kind of frustrated me, and this is just kind of an issue with Windows in general, is that in like Nix machines, you can just install packages and it works great. In Ansible, they do have modules for like NuGet, like for the package manager that was like developed for Windows. But I found that like the couple of things that I wanted it to do, I was not able to like use that. So if there was a way to automate using an installer, that would be phenomenal. Because obviously, if you have to install something that only has a GUI front end on a Windows machine that's going to be used for a developer, then you're kind of up the creek without a paddle. So I'm going to kill it here because this reboot is taking a little while longer than I expected it to. Actually,
I think it rebooted.
Perfect. Oh man, just as I was saying that, just as I was unsure. I should have believed.
Okay, I was on the next reboot task, I think.
Wonderful. I was like, why is that not working?
Because they came back up, did something, and rebooted again.
Yeah, yeah. So that was the, yeah, that's, ugh. Okay. So I am going to cut it there. The second reboot is going to take, actually, I'm not going to cut it there. I'm going to keep equivocating because I want to give Joel time to be able to give his presentation.
Pretty fast.
Okay, cool. I'll keep standing up here and stuttering on camera in the meantime. So,
Peanut calories enjoy.
yeah, no worries.
So, how's your day?
It's going good. Windows is taking a little while. Alright, yeah. I'm going to cut it there. But trust me, it does promote the domain controller. It's very beautiful when it does. So, thank you for listening. Yeah, I did not I forgot to sacrifice the goat to the demo gods.
Just use live demos.
Yeah.
That would have been fun. You could have done like a sample editing controller promotion.
Yeah.
Yeah, right.
Alright, we're gonna
Yeah.
get the water cord here. Stop the airports. Janky enough. Cool. That's gonna fall. Good enough. Alright, cool. Alright, let me just pull this up here.
Do you put those sunglasses on top of your actual glasses?
Yeah, yeah, sure.
Really glad I had the camera pointed right there.
Yeah,
'Cause I just
cool.
got caught.
Yeah, no. It's my new profile picture for the next 3 years. Alright. Cool. Oh,
Oh, no.
I'm not on my own first slide.
You're going to want to turn notifications off as well.
So, just gonna unplug that real quick. good. My computer's black screen. Oh, it's fine. All right. Cool. All right.
You could use mine then.
We're gonna see if this works. Yeah. Cool. Oh,
I got you.
nice.
Don't want that to.
Right. Okay. That's all right.
That's the one.
Start this over. So, tech lead behind the scenes. I'm Joel. I'm a second-year CSEC major. I'm a mobile hacker, Python weirdo, but for the most part, I'm the RC3 tech lead. A lot of you probably attend RC3 or have at least heard of it. So all the challenges and stuff, I make those every week now with the help of Simon. So, like I said, I basically build the easy, medium, hard challenges, all that stuff, all the infrastructure, everything that's used, not the whole infrastructure, but a lot of it, the stuff that's built up every week. So servers, services, all of that. The stuff that it runs on, it's already built. That's done by Susan. But you know, I also work with whoever is presenting that week. So if it's web week, that's Ohan or Bryson. If it's cloud, that's Susan. That kind of stuff. So all the stuff that's in the slides needs to correspond to some of the stuff that's in the challenges, and the stuff that's in the challenges has to correspond to stuff in the slides. So what could be so hard? Well, how do you stop cheating? When I have to deal with 40, 50 people who have to connect to a server or have to be distributed a VM, if they have a VM file, they can run strings on it, they can grep, they can reset root passwords. There's a million different ways for them to get the flags that are on the file system. So how do you do that? Well, you try a remote server. So if you're doing a remote server, how do you stop 40, 50 people from screwing up a server for everybody else? It's a big problem. You can, mount it read-only or use Docker. There's a couple different solutions, but you have to figure out how to implement them the best way. You have to try out the solutions. It's a lot. It's a whole process that goes into it. So keeping things configured with 50 people connected, it's a challenge. So a lot of the setups that I like to use, AWS for everything. We used to distribute VMs. I distributed a VM the first 1 or 2 weeks, and within those 2 weeks, people had already cheated. So it was time to move to a different setup, and kind of knew that was going to happen. I cheated when I was doing them, of course. It's easy. So the goal is to make this a learning process, not a cheating process. If you learn how to win, you're not learning. So AWS is really great. It's a lot easier than having to distribute a VM. I give them a host name or an IP or something like that. I restrict it to RIT's IP range, and then only RIT people can get at it. I'm not going to worry about it getting popped and thrown into a botnet. Security groups are really, really important. So usually I go with Ubuntu Debian. It's what I'm most fluent with. Leave me alone. I only ever use an old version of something if I have to. I think it was Linux Week or something. Maybe pen testing, and I used an old version of Ubuntu because I needed to be able to have it exploitable. And within 3 days, I get a message from somebody, and they're like, "I popped your box. It was vulnerable to dirty cow." And I was like, "Well, I knew that. You were supposed to do that." So yeah, only ever use old versions if I have to. Old versions of Apache, stuff like that. Try to avoid older versions of things in general. You don't want people kind of doing malicious things to this, even when you tell them not to. It's hard for them to say no, and it's if they weren't there or they didn't listen, they can plead ignorance. So it's important. Usually also try to avoid graphical UIs. I did put VNC in the challenge once, and that did not end well. I came back to it, the password was changed, the whole config was gone, the actual challenge wasn't even there. It was a mess. You can't control how do you put ACL, so to speak, on a graphical UI. You need to stop people from messing with the desktop and all that. It's a mess, So things to remember: Amazon doesn't like it when you pen test a box without telling them, as you might expect. They also don't like you pen testing from a box without you telling them. So it's really easy to apply. You fill out a little form, you give them an instance ID for whatever you're setting up, and they just say, "Sure, go ahead. We won't get mad at you this time, but don't do that again." And then they let you do it again. So there's a lot of conclusions also that people can jump to, but often it's not the right one. When you're trying to create a challenge, it has to be something that they can understand, that they can infer the solution from. and that they can easily jump to or Google. It can't just be like, I made a hard challenge once where I rolled my own crypto, and nobody knew how to fucking solve that, because how are you supposed to know how to solve that? I didn't give any clues. I basically said go deeper because people wanted it harder, so I made it harder. You start removing hints and it starts getting a lot harder. But along with that, you have to come up with a hint that's good enough that will give them enough information but not too much information. So this is all part of the challenge-making process. Me and Simon were putting challenges together today. He's like, what do I do for the hint? I was like, yeah, you kind of just figure it out as we go along. Because it's hard. You have to be able to hint where they need to go without just pointing at the answer. So that is part of one of the challenges. So a couple examples. Cloud Week. Clouds. I don't know clouds. I don't know AWS, any of that stuff. I'd set up like 2 EC2 instances in my life before Cloud Week. I'd never set up an S3 bucket, policies, IAM policies, user permissions, none of that. Luckily, there's an operations person on our e-board. Thank you, Susan. So, Base God Susan basically was like, it's really easy. You just got to do these easy things. And drew it on a whiteboard, and I still didn't get it, and then eventually got it. AWS isn't that hard once you get it. Once you get it, you get it, I guess, is the thing. You kind of got to sit there. You're going to have to take out like a couple hours and just like start poking around in interfaces. It's kind of like everything else. You just got to work at it. Now I know how to do things in AWS. Something I still don't understand, how people make insecure S3 buckets. I mean, this seems like really self-explanatory, right? Like, everyone in the world will have read access to this bucket, and then they just click next and it's fine. Cool. Web Week 2. Or Web Week was not week 2, but example 2. So I'd really like to be good at web design. It's just like really tedious. You know, CSS, want to center something, and a whole day later, you get it centered and you can go back to what you were doing. There's also a role on our e-board for that. So Bryson and Ohan, these guys, they actually enjoy doing web for some reason. Don't know why, but something about the tedium with the, pixel alignments or whatever, they really like it, So they are good at making challenges. I've dabbled with web, but never to the extent that I would need to be able to make challenges that we did. So like SQL injection, XSS, server-side request forgery, all that kind of stuff. That is like so crucial to pen testing and like web pen testing, web security, all that stuff. Not my strongest forte whatsoever. I know a lot of people who are good at it. I'm not good at it. So thank you for those people for doing that. But if you ever have a web question, don't ask me. Ask one of them. That's like that was his job. That is his job. So yeah, good stuff. Last one. Pen testing. So here's me on a Wednesday doing nothing, and then I realize it's Wednesday and challenges are due on Friday. Shit. So our treasurer happens to be the founder, so to speak, who's in charge of the pen testing interest group for RC3. Mike, he is our treasurer. He manages everything, all the money, all the good stuff. We were like, hey, we should put together a pen testing network. Mike was like, great idea. I was like, it's Wednesday. Can't really set up multiple machines that need to be pen tested. You need, you need to move laterally throughout a network. They have to be connected. They have to be set up, configured. You have to have vulnerabilities. It's a lot of work. So there's a couple things we could have done. We could have set up a crappy pen test network, or we could ask Grim, who's our sponsor, and they just set up a pen test network. So quick, take the easy way out. Message Grim. Well, Jamie, not Grim. This is pseudo conversation. So we were like, Grim, please let us use your cool thing. It's great. It's what we need right now, and we don't want to do it ourselves. We didn't say that, but And Grim was like, okay. And we had our asses saved yet again. It's not bad to ask for help. I kind of talked about this here. Yeah, I got my ass saved a lot. It's good. It's a good thing. This is supposed to be a learning role. It's supposed to be a learning position. I told that to Simon when we accepted him. It's meant to be a mentorship thing more than anything. it's important that you learn from this, that you learn the insides and outs of what you're talking about. Because if you don't know that, you can't teach it. Like, people like to joke, you know, professors stay here for like 20 years or whatever, but it takes a lot of time to know that stuff. And once they know it, they're really good at it, right? There's a reason that they're teaching you, because they know what they're talking about. So tech lead is hard. It's a lot of work. It takes up a good amount of my time and a good amount of my sanity. But there's a lot of thought and effort and a lot of love that goes into every single week. And there's a lot of things that are also held together with, you know, duct tape and chewing gum. It kind of just happens. So I have a minion now. I've mentioned he's Simon, cool paintball guy. He's got a, you know, that thing. He face plants a lot. So he helps me stay on track and focused and stuff. So thanks, Simon. Last thing really is just come to RC3. I'd really recommend it, even if you're not in security. It's a great way to learn things, learn different topics, kind of familiarize yourself with the whole spectrum of security. That's pretty much it. If you want to reach me, these are where you can find me. These slides I should put on my site, so if you want to read them again, hit me up on one of these places, and I'll be sure to link it to you. But other than that, that's it. Does anybody have any questions? Cool. All right.
Thanks, Joel. Last person who's going to present tonight is going to be Tom. We'll be talking about VoIP security. So, get hyped. Yeah.
So I heard there's only one outlet up here.
Yeah. I don't trust that streaming laptop because I know.
There's another one right behind.
I wasn't kidding.
Right over there, yeah.
There's one on the side.
There's one on the side?
Yeah.
What a game changer. Oh my god, I could have plugged in my laptop.
Yeah, I was a little confused why you weren't plugging it in right there.
Jeez.
Oh, wow. I should. Wait, what?
Yeah, right?
Wow. I thought those were just a video.
Yeah.
Now,
We're used to the other
a moment of truth here.
Yeah. I can give you a hint if you want.
It doesn't work, it's my laptop because
We can use mine if it doesn't have a demo.
it does not. Oh wait, hold on, I gotta go to.
Yeah, if you don't have a demo, we can use it. Ah, cool.
Why is it not showing? That's interesting.
Nope.
Something?
It did something.
Yep.
Oh, we did it. Perfect.
Yes. Is it working? Yes. Cool. All right. So, I'm Thomas. I really like VoIP. I'm not very good at it quite yet, but so last year for ISTS, I was on the VoIP team with Anthony, and we did a lot of cool VoIP stuff with that. And then, I don't know, my first co-op, I did some collaboration stuff, which is basically VoIP and all that. And last year, end of the semester, I was taking, what was it, authentication security models with Heim. And Heim made you do a project. It could be anything with security, but it had to be some sort of project that you write a blog post on. So one of the things that had frustrated me in the past was there's this program called Asterisk, right? And it's an open source VoIP sort of server. And there was really no good documentation on securing Asterisk. Not that there's good documentation in general on Asterisk, but there was no good documentation on this. So I set out to try to do a full, like, secure thing with Asterisks and a couple boxes and that. So this is sort of what I came up with. Now, before we really do a deep dive into it, let's talk about some VoIP basics. So with VoIP, you got a signaling protocol. In this case, SIP, Session Initiation Protocol. So what that does is it carries information about, like, your phone numbers, call itself, or no, sorry, phone numbers, where it's going, who's it from, IP addresses, that sort of thing. Extensions versus a media transport protocol, sorry, where you actually have the physical phone call being transported. So your voice is converted into a UDP packet, RTP, and it's sent across the wire, and you can intercept that and listen to it. So the two media transport protocols we're going to be talking about are RTP, which is real-time protocol, and SRTP, which is secure real-time protocol. As I mentioned, the call manager server that I'm using for this is Asterisk, and then for our VoIP endpoint, I used Zoiper. That's another free open source sort of soft phone, it's called. So hard phone is a physical phone on your desk, and a soft phone is one in software. So I'd used that previously, and I just used it with this.
So real quick, do you have Flux turned on?
Oh, is it doing it on there too?
I think so.
It's not Flux, it's whatever Linux's version of Flux is.
It's Linux Flux. Or what I've been taking recently to call GNU Plus Linux Flux.
Okay, Stallman. Okay.
Richard Stallman. So we like to make people
So can you still see that? Oh, wait. Left shift or middle click. Oh, here we go. Inactive. Wait.
Don't worry about it then. It still looks fine, or it still looks. You can still see it.
You can still see it. Okay.
Yeah.
Then I'm gonna keep rolling with it.
I go to bed at normal times. This is good for me.
It just looks like you put a nice theme on the slides.
Yeah, that's it. Let's go with that. So, SIP, as I mentioned, it's our signaling protocol. It uses port 5060, and it uses HTTP response codes. So it's very easy to see if something went right or wrong during a phone call. So if you get a 200 back, that means, okay, your call's going to go through, everything's good. But if you get a 400 or a 300 error, you know something's wrong. Over here is just a super basic diagram of how a SIP call is initiated. So you send messages to your proxy server, SIP proxy, and then that sends it to the other phone. And it sends a bunch of messages back and forth, like trying, ringing, and then here's where the actual phone call happens with the RTP and RTCP. RTCP is just information about the phone call, so statistics. The topology I used for this, basically two boxes, two Asterisk servers trying to communicate with one another, and just one phone connected to each server. So I had a couple extensions. They're all on the same subnet, but routing doesn't really matter. And you can see where SIP traffic would go. So SIP doesn't go in between the phones themselves. It goes in between the servers. But the RTP audio traffic actually goes in between the phones themselves. So in Asterisk, you have two things to set up like a phone network. You have a channel module and a dial plan. So the channel module sort of says, okay, I have this server and it's going to be running this and it's going to have these settings, etc. Versus a dial plan which actually has, okay, I have this phone call and it's going to this number, where do I send it? And it uses that with different pattern matching, and you can do some more stuff with that. And I'll show you some examples here. And Asterisk has two different versions of this channel module for SIP. It has sip.conf, which is sort of the older sort of thing. It has pjsip, which is a lot newer. But I ran into some issues with pjsip, which I'll talk about later. So sip.conf, we have basically at the top you have a register command, which basically says I want the servers to register to each other. And then you have information about the other server. So the other server, Buffalo in this case, was going to be a peer. You have a secret. Context, that refers to the dial plan. So if I get a call from this server, what context am I going to apply to it? The host, in this case, the IP can be dynamic. And then these two commands or lines, disallow all and allow ULAW. So those are for codecs. So what I have here is manually disallowing all codecs and then manually allowing its G711 MULA. So, and then here's a endpoint, basically all the same thing, but this context is phones. Don't worry about that. DTMF is just so you type a number on the phone and it makes a dial tone. That's what DTMF is, dual tone multi-frequency. And here's the dial plan. At the top, general, auto fall through. That just means if it's not in that context that it comes in on, fall through to a different context. In the phones context, you're including both the internal and the remote context here. Buffalo incoming, you also want to include the internal context, which is where your phones on this server, which is Rochester, are connected to. And then all this is really saying is, if I get a phone call from this extension 1 and then any digit, dial that extension. And then if it's not available, say it's not available, and then just hang up. Very simple. And then this is Zoiper, just configuration of Zoiper. You basically specify where your call server is, what your username or extension is, your password, and then you want to use an outbound proxy because otherwise you won't be able to reach other call servers and phones across other call servers. So that's very simple, and all you do is you type that stuff in, click register, and your phone should register. And then once it does, you can start making phone calls. And during phone calls, you can capture them in Wireshark, obviously, and this is what a SIP message sort of looks like. So you have SIP, and in this case it's ringing, and it just has information about the call. It's from these IPs, received from wherever, what port was it received on, caller ID, that sort of thing. And this is kind of complicated, but a much easier way of looking at it is looking at the call flow, because Wireshark can also show you different call flow statistics. So this is everything that happened up to after this phone call. So you have a bunch of messages. The phone's trying a bunch of different stuff. The servers say, no, you're not authorized for this, and that changes a little thing. And then it says, okay, you're good. And then it gets the messages back, and you can see here, RTP's traffic starts to flow. So that's where the phone call actually starts. Now the thing that made me want to do security with this is if you capture that RTP traffic, you can play it back. So on Wireshark, if you capture whatever RTP, and you know it's RTP, and you decode it as RTP, and then you do some stuff in Wireshark, you press this play button, you can hear me saying hello. I don't have that capture anymore, but so if you intercepted a phone call that was unencrypted, and you have an important business transaction, for example, and you listen in on it because it's unencrypted, bad things happen, right? That means we have to secure both the signaling and transport. And that requires having fun with certificates. So we need to use SIP TLS. So TLS is used in HTTPS, transport layer security. That uses certificates. So it just abstracts it, the security to another, not another layer, but you know what I'm talking. It's very similar to HTTP, right? X509 certificates, very standard. You use certificate authorities, so servers that issue the certificates, and then we enable SRTP, secure RTP. Thankfully, though, Asterisk comes with a ton of nice scripts, right? So install prereq, which is all the prerequisites before you install, and then this one, which I use, which is AST TLS cert. That creates the certificates that are necessary with some input parameters. So in this case, if I create the certificate for the Buffalo server, I run this command and then put the certificate in that directory and the key in that directory. Super simple. Until you get to, you need to create certificates for a bunch of different servers and a bunch of different phones. So I made this nice little table for all the certificates that I needed to generate. And this was a couple commands and keeping them all in line and putting the right IPs down, that sort of thing. So that's complicated. That's something that probably could have been scripted, but I didn't really care at that point, right? So now we have all the certificates. They're all on the devices that are necessary, all that good stuff. So then we move into the sip.conf file, right? We got to add some stuff to the configuration. So obviously TLS enable, we want it to use TLS. Bind address, we want to explicitly specify to use port 5061. SIP TLS generally uses port 5061 because it's 5060 plus 1. Not very creative, but and then you specify the certificate file, the CA file, so what file to verify against, what ciphers to use, all, and then the client method, v1. it's only v1 because Asterisk is kind of dumb and doesn't support a whole lot of encryption stuff. So it doesn't do, what is 1.2 the standard at this point? Jill?
TLS?
Yeah.
You're putting me on the spot. I thought it was in like version 2. But
So it's old.
Yeah.
Let's go with that, right? And then, so for Buffalo in this server config, you want to explicitly specify the host, because otherwise when you're trying to check the certificate, right, if this is host equals dynamic, then it doesn't know the IP address and it yells at you. So you need to specify the IP address, and then you want to specify that the transport is TLS. And then at the bottom here, you also want to specify that transport equals TLS with the endpoint as well. Now we move on to configuring the TLS with the soft phone. That requires, first, you want to add an extra CA certificate. So to explain this best, so you're running Windows, right? And you go to a website. In order to trust that certificate that's on the website, you have different CA certificates already on your computer. So you have like VeriSign, DigiCert, Microsoft probably. So anything Microsoft is digitally signed correctly, that sort of thing. But because my CA is not trusted, I had to explicitly trust it up there by adding it. Then I want to load the domain certificate, which is basically the same thing, and then use this disable certificate verification, dangerous, do not use. But I used it anyway because otherwise it wouldn't work. Then on the, let's see, count options, I use the TLS transport, and then I also specified that when you're using the media to also use TLS, but don't use SRTP quite yet. Because over here is where we enable SRTP. You basically specify for the endpoint, I want to use encryption, yes. And then you have to go into the dial plan, and you have to specify, I want to use secure bridge signaling. So signaling, TLS, SIP. So I want to make sure all that's secure. I also want to make sure all my media is secure. So you want to set both of those to true. Now you'd have to do that for every context, every extension, I believe. But in this, I just had to do it for one on each, basically. And then I go over here to RPort Media, and I use SDES SRTP. SDES stands for, let's see, Session Description Protocol Security Descriptions.
Gotta love this.
Yeah, right? And all SDES really is it runs with SDP, which is Session Description Protocol, and that sometimes runs in SIP, and it just has more information. So you can carry more information in a SIP message. So then we make a phone call that's encrypted, and this is on the Asterisk CLI, just giving you an idea of what it looks like. You can see that Asterisk, or the phones, are trying to negotiate different crypto algorithms for, I think, SRTP in this case, and they try AES 256, and then they try AES 192, and then they go, okay, let's do 128 for some reason. I don't know why it negotiates down to 128, but it does. And then you basically, you set everything that needs to be set, so the bridge signaling, and then you dial the number. And then it rings, it answers, and your phone call's going. And now here's the cool part, right? So before you were able to see the phone call, you were able to play it back and like hear the voice, right? So here's the difference. Unencrypted versus encrypted. So technically, you can capture this and you can play it back. But all that sounds like is static. You can't hear a voice at all. So sure, you can get it, but you're not going to get anything from it, which is awesome. Now, going through this whole thing, obviously, Anthony will know because Asterisk, there's a ton of caveats, right? So one of the really weird things that I encountered, let me go back here. Yeah, this line. So this line at the very top, what I had to do was comment out all this encrypted stuff, right? TLS, leave the register, have the servers register to each other with SIP, and then I had to comment out the register line and then do the encryption stuff. So the servers had to register without TLS before I could use TLS. And I don't know why that is, but that was very interesting. And then the other thing was, as I mentioned, using the dangerous do not use button, because otherwise it wouldn't trust the certificate and it would not like it very much. Yes, Joe.
Is that just because you self-signed it?
Probably.
Okay.
Which is what I get into here, where you have a couple of things that I could improve upon here, right? So certificate distribution. How do you distribute all these certificates, right? So you generate all these certificates on a certificate server, AD certificate services, right? How do you get them to every box? If they're normal boxes or soft phones, that's fine. You've got them on an operating system. But what if it's an actual physical phone? How do you do that? Like TFTP would be my first guess, but I don't even know, right? Cisco has a way of doing it, but that's Cisco land. This is open source land. And as I mentioned, to make everything sort of verify with domain services, you can use an enterprise certificate authority. So Microsoft Active Directory certificate services, you can add everything to the domain, and then it will explicitly trust that domain since it's been added to that. Configuring TLS with a SIP provider. So as I mentioned, one of the things that sort of pushed me to doing this was I look up a config for TLS between two servers, and these providers would give you a config to put on your box, but they don't tell you what they use. So you don't know what settings to put on the other box and that sort of thing. So I'd like to actually get that working possibly. And then PJ SIP. So PJ SIP's the sort of newer module, newer library for SIP, and it's being used more and more. I'd like to use it in this, but when I tried to use it, it would also not work. It had something to do with that registration thing, right? So those are all things I'd like to do in the future if I have time, which I don't anymore. So now, if you want to read more, there's this big long URL where I actually had to do a write-up for this. A lot more detail, a lot more info, kind of cool. And any questions? Yes.
So you said you use VoIP, right?
Yeah.
So key negotiation, they were doing that over the SDES session within SIP, I'm assuming? Or,
Yeah, I think so.
All right, I was just curious.
Yeah, SDES has
There's
all
like literally 32 RFCs dedicated to how you can negotiate keys, and nobody actually implements all of them. So I was just curious.
I mean, maybe it works. So Zoiper updated recently. Maybe it works in the new one, but I don't know. I haven't tried that.
Probably not.
No. Other questions, comments, anything? Learn VoIP. Take Harpence's VoIP class. That's fun. Awesome.
Thanks.
Thanks.
All right, that's everybody. So thanks for coming. Hope you come to the next one.
How do you do?
You did what? Hold on.